We've come to a point where we're going to need the square root in order to solve some problems. And the square root operation is a little more complicated than perhaps meets the eye. And so it's time that we look at it and look at some of the little details which you may not be aware of about the square root. Part of this is the fact that we treat the square root as a mathematical function. Now we're going to study functions in a later chapter, but a function has a single output. And so we're going to agree that a square root gives a single output of a positive number, unless if you're taking the square root of 0. So for example, the square root of 49 is equal to 7, and that's because 7 squared is 49. Now, we don't say that the square root of 49 is negative 7, but it is true that if you squared negative 7, you would get positive 49. And so, in a sense, the negative 7 is a square root of 49, but when we use the square root symbol, we only write positive 7. We don't write the negative 7. All right, so what's going on there? Well, again, the way we define the square root is as a function which has a single answer, not two possible answers, and we just agree that for simplicity, let's make them all positive. All right, so, but it's an important consideration to think about because it can lead to some misunderstandings. So for example, the square root of 7 squared is 49, and that equals to 7. And so it looks like when you take the square root of this, your square root operation is canceling the exponent too, just leaving the number 7. But what about this situation? If I had negative 7 in parentheses squared, that does equal to square root of 49, which equals to 7. And so it's not quite as simple as saying I can just take the square root to cancel the 2 and get negative 7. All right? It wouldn't work, would it? And in a more general case, if you just thought about x squared, then it would be oversimplifying. This would be wrong, by the way, to say that this is just equal to x. This would work as long as x was a positive number, like here. That would work, wouldn't it? But if x was a negative number like this, then it would not work. And so, strictly speaking, the square root of x squared does not equal to x in all cases. Well, how do you get around that? Well, that's how we get around it. The square root of x squared is actually the absolute value of x. And by using absolute value, then we take care of the negative issues. So for example, up here, this would be the absolute value of negative 7. And the absolute value of negative 7 is still positive 7. All right, so here's something what you might not have known about square roots. The square root of x squared is going to be an absolute value. All right, so where does that come into play with what we're doing? Well, let's look up this problem here. We've been playing with 49, so let's solve this problem. Solve x squared equals to 49. Now, you can easily see that there are two answers to this problem. Positive 7 will work, but also negative 7 works. Square a negative 7, you'll get 49. So there are two answers. We could solve this by factoring, incidentally. Bring the 49 to the left. It will factor very nicely. You'll get two different factors which produce two different numbers, 7 and negative 7. But there comes a point where we might want to use that square root to solve. And so to solve this, I could say, well, why can't we just take the square root of both sides? Okay, and that's okay as long as you take the square root of both sides at the same time. Then that's permissible. But now this kicks in, and the square root of x squared is an absolute value of x. And then, well, how do you solve this equation? Well, we're going to study absolute value equations pretty soon. That's going to come up. But for now, suffice to say, there's two answers to this problem. Positive 7 and negative 7. Because absolute value 7 is 7 and the absolute value negative 7 is 7. And so we have two answers, 7 and negative 7. Alright, so it would be okay to use the square root provided you think about this absolute value business. Well, here's some good news. We don't have to think about the absolute value business as long as we make another adjustment here. And so what's normally done, and we know that we're going to get two answers which are the same, except opposite in signs, in this case 7 and negative 7. And so because we get two numbers with opposite signs, we can accommodate that here. When I take the square root of both sides, I can introduce the plus or minus symbol, and then that allows us to dispense with the absolute value business and just call this x. X equals to plus or minus square root of 49, plus or minus 7. Alright, so this is an alternative to thinking about absolute value, and I think you might prefer that. I certainly do. And what does it mean? It literally means x is equal to positive 7 and also to negative 7. So there's our two answers. Alright, now that's the crux of what's called the square root method of solving. And so let's work a little more complicated problem here. Here's a problem where this square root method is really quite valuable. Solve parentheses 5 minus 3x squared minus 17 equals to 0. Alright, now we could attempt to do this by factoring, but it won't work. You know, you could square this out and collect all your terms together. And you just have to trust me on this, it will not factor. Alright, and so, but it is set up for the square root method. And I want to kind of explain that in detail. When can you do the square root method? And I'm first going to start off by adding 17 to both sides. In other words, I'm going to isolate the squared term from a constant. And so add 17 to both sides. This gives me 5 minus 3x squared equals to 17. And here's where the square root method kicks in. And let me just, write that out for a moment. The square root method is used when you have a variable term squared equal to a constant number. That's when this works. And now if I had x on the right side, it won't work, because you take the square root of x and you introduce all kinds of complications. But I can take the square root of 17 and calculate that without much problem. And so long as you have a variable term that's a perfect square equal to a constant, then you can take the square root of both sides and it's going to work very nicely. So let me go ahead and do that. Alright, so I'm going to square root both sides, and in so doing, again, in order to avoid that absolute value business, all I need to do is to write a plus or minus symbol in here in front of the constant term. And so when you use this, then you can just go ahead and cancel the 2 with the square root, and that just gives you 5 minus 3x. So 5 minus 3x equals to plus or minus the square root of 17. There we go. Now we can finish. We can finish the problem, and this one's a little bit tricky. Yeah. Well, let me do it. Subtract 5 from both sides. So I subtract 5 from both sides. I can't combine these together, so I end up with negative 3x equals to negative 5 plus or minus square root of 17. And to finish, and this is where I saw the trickiness coming into play, I'm going to divide by negative 3. And so our answer is going to be x equals to negative 5 plus or minus the square root of 17 over negative 3. And that's probably not how I would write the answer, because I don't like to have negatives in the denominators. So I know this introduces yet another issue. This is actually pretty good as an answer, but I'm going to multiply top and bottom by negative 1. And that will give me a positive 3 here. When I multiply negative 1 times negative 5, I'll get positive 5. But here's the funny part. When I multiply negative 1 times plus or minus the square root of 17, I'll still get plus or minus the square root of 17. And so the negative won't affect the plus or minus, because that just flips the pluses and the minuses. And so we could write our final answer this way. X equals to positive 5 plus or minus the square root of 17 over positive 3. So, alright, well anyway, the point of the problem was to separate the constant from the variable term squared, and then to take the square root of both sides and use the plus or minus symbol. The rest of the problem was just algebra. Just, bringing the 5 over and dividing by 3 to get this answer. So now this is two different answers, and it's usually okay to leave it like this. But I want to stress the fact that we have two different numbers here. And so x would be either 5 plus the square root of 17 over 3, or 5 minus the square root of 17 over 3. And pretty soon we're going to ask you to calculate these on your calculator. And so to do that, you will need to separate them like this in order to punch in on a calculator. So there we go. There are the two answers to that. And the square root method, if you recognize it when you can use it, then it can save you quite a bit of trouble. Okay, now we're going to move on and look at problems where we can't solve by factoring and we cannot solve by using the square root method. So that's going to generalize our situation and head us toward the quadratic formula.